Ladies and gentlemen, good evening and warmly welcome to you all. I hope you all can hear me clearly. Before we proceed, I would like to ensure that everybody is audible and visible. Can you please confirm?
Yes, we can hear you.
Thank you. Tonight, we gather here for an extraordinary session as part of the Agni AGAX series. I would like to kickstart our event by sharing a powerful quote by Mr. Ambris Stepler. We are entering a new world. The technologies of machine learning, pattern recognition, speech recognitions, and natural language understanding are reaching a nexus of capability. The result is that we'll soon have artificially intelligent assistants to help us in every aspect of our lives. Let's take a moment of reflect on this card and share your thoughts on it. Do you believe that beyond on our scalps and transformative era powered by these technologies? I invite you to join the conversation and share your insight. Without any further ado, I would like to extend a warmly welcome to our distinguished keynote speaker, Engineer Chinthaka Jayaweera, the respective member of the Faculty of Engineering Academia, and all the other esteemed registrants. Now, let us delve into today's topic, Introduction of Machine Learning and Industry Applications of Machine Learning, organized by IEEE Student Branch of Southeastern University of Sri Lanka. It is my pleasure to introduce our esteemed speaker for tonight's session, Engineer Chinthaka Jayaweera, a renowned deep reinforcement learning engineer and researcher at Invariant Trading, USA, and former AI engineer at Analog Inference Company in California, bring a wealth of knowledge and expertise to our session. With a strong academic background as a former member of the Department of Electrical and Telecommunication Engineering at the Faculty of Engineering, Southeastern University of Sri Lanka, Engineer Chinthaka Jayaweera is proudly produced by our esteemed faculty. Throughout his career, he has successfully completed numerous AI and machine learning projects, showcasing his expertise in the field. We are privileged to have him as our keynote speaker for these sessions. Ladies and gentlemen, please join me in giving a warm welcome to our keynote speaker, Engineer Chinthaka Jayaweera. Over to you, sir.
Yes. Yep. So first of all, I want to thank you, Agni AGX team and Mr. Chamot, for inviting me to this session. And actually, thank you for the introduction about me. Yes. I think, yes, I think without taking much time, we can start our presentation and let's discuss about the AI. Yep. I hope you can see my screen.
Yes, it is visible.
Yeah, thank you. Yes. So, yeah. So, guys, I hope you can see my screen, and I hope everyone can hear. Yeah. Okay. So, these are the objectives of today's session. So, first objective is providing undergraduates with an introductory understanding of AI and ML, and providing a roadmap to develop the necessary skill set for industry readiness for you all. I think most of you guys are from university students. Most of you guys are university students, and I think it is good to start from at the very beginning of the AI things, right? So, so as the content, first we will talk about first we will talk about introduction to AI and ML, and under that topic we will talk about what is AI and introduction to machine learning and introduction to deep learning and introduction to computer vision, and we will discuss about what is MLOps, like that. And as the second part, we will discuss about part to the industry. We will discuss about common skill set that may be helpful to you, and part to get your first job in the field of AI, and tips for LinkedIn profile. You know, LinkedIn is a very powerful platform to find jobs and connect with more community in the field of AI, not only for AI. In the most of industry related professionals are, you can find through LinkedIn. You can contact them. You can share your knowledge and learn a lot of them. And actually, you can find jobs as well. So after that, we will move to frequently asked question for projects. Yes. So yes, let's move to introduction to AI and ML. Yes. So as I mentioned before, first we will talk about what is AI and introduction to machine learning and introduction to deep learning and introduction to computer vision. Finally, we will discuss about introduction to MLOps. Right. So first, what is AI? Actually, AI, we can divide artificial intelligence into mainly two categories. We can call it as AI and AGI, or artificial narrow intelligence and artificial general intelligence, right? So let's first talk about artificial narrow intelligence. So artificial narrow intelligence, or ANI, refers to a computer's ability to perform a single task extremely well. In other words, actually, if an AI has the ability to do a specific task very well, we can call it as an AI, right? As an example, you know, we are using face recognition systems in our mobile phones, and we are using tools like ChatGPT to generate content. And yes, so, but they can't do all tasks that human can do. Those AIs only specific in a specific area. They can perform tasks extremely well on a specific area. That's how they are working. And you may have heard of some AIs can handle a specific task better than humans sometimes. As an example, we can take AlphaGo. That was an AI. If you don't know, it is an AI that developed in 2016, and it could able to defeat world champions in the Go game domain, right? So that kind of AIs are there in our world. Yes. Meantime, we have this artificial general intelligence also. So what is artificial general intelligence? It is the hypothetical ability of an intelligent agent to understand or learn any intellectual task that a human being can, right? So you can see it is hypothetical ability. Yes. So in other words, if an AI has the ability to do any task that human can do, we can call it as an AGI. Actually, still this is a concept. That's why we are calling it as a hypothetical ability, right? But at the current world, we can't find any artificial general intelligence. We are still in the artificial narrow intelligence age, right? But we have AGIs in movies like Terminator, iRobot. Those robots can do any kind of task human can do. Those we call it as artificial general intelligence, right? So these are the main two parts of the artificial intelligence. So from this slide, we are going to focus on this artificial narrow intelligence. That is the intelligence that we have in our world right now. Yes. Right. Actually, yes, these are the main task set that artificial narrow intelligence has. You can see there are so many branches in the artificial intelligence we can divide. The first part is machine learning. Actually, this machine learning is the main tool for the AI, main technology to develop an AI, right? Under this machine learning, we can find deep learning, supervised learning, and unsupervised learning likewise, right? And using these machine learning techniques, we can develop tools like natural language processing tools, expert systems, and vision modules, and speech recognition systems, and planning systems, and robotic systems as well, right? So, as I mentioned before, we can call this, yes, this machine learning is a tool. This is a what we called technology. We can call it as a technology and a technique. This technique can be used to develop these kinds of AIs, right? That is the simple thing, right? Let's talk about natural language processing first. Yes. Under natural language processing, we have this content extraction, classification, machine translation, question and answering, text generation. I think most of you have familiar with ChatGPT. ChatGPT, these GPT models are based on natural language processing domain, right? It can extract content. If you provide an text to ChatGPT, it can understand the content and it can summarize it, and it can provide some more details about that text. Likewise, it has the ability to do those kind of tasks very well, right? And it can do classification tasks also. It can classify whether the given text is it is a positive text or negative text. Likewise, it has the ability to do that kind of things, and it can do some machine translation stuffs also. I don't remember whether machine ChatGPT can translate English into Sinhala. I don't remember. I think it is only in English. Yep, need to confirm about that. But we have machine translation engines also. Google has machine translation engine. I think most of you guys have used those tools. And question answering, of course, we can take an example from ChatGPT. And text generation. Yes, again, ChatGPT. These GPT models are very powerful. They can do almost every task in natural language processing, right? Yes, that is all about the natural language processing task. Those are artificial narrow intelligence tasks. And after that, if we talk about expert systems, actually expert systems are computer-based systems that emulate the problem-solving capabilities of human experts in a specific domain, right? As an example, we can think of an application like diagnosis and treatment recommendation system used in medical field. Likewise, you know, to develop that kind of systems also, we need these machine learning techniques. And of course, the previous topic is natural language processing. For that one also, we need machine learning to develop those kind of models, right? Yes. So yes, let's talk about vision systems. Actually, this image is somewhat outdated. Under the vision category, computer vision, we call it as computer vision. There are so many tasks we can do. In here, we only have image recognition and machine vision. Actually, under this, we have more tasks. We will talk about later in later slides. I will give you an brief introduction about computer vision also. And yes, after that, we have speech, right? There are models that can generate text from speech. We call them as speech to text engines. And some AI has ability to generate audio from text, generate speech from text. We call them as text to speech engines. And in addition to that, we can use AI in the planning. As an example, you can take Google Maps. It has a planning module. Like if you ask a path to go where in the world, it will plan the path, right? If you ask directions, it will give you directions. It has the ability of planning of paths by considering so much information, like whether there are traffic in the road and how many, like others vehicle, how much time has taken to arrive other vehicles. Using those information, it can calculate how much time will take to arrive. Likewise, those kind of planning stuffs also can be achievable using artificial intelligence. And also, of course, in the robotic field also, we can use AI tools. Actually, for the robotic tools, we can use natural language processing to generate text, and we can use speech to text and text to speech engines in the robotic field. And we can use machine vision to detect objects in the robotic applications. Likewise, guys, all of these areas are depend on, like, if we take natural language processing, it depends on the machine learning. And if it took robotics, it depends on computer vision, speech, and NLP tasks, right? So there are so many narrow intelligence tasks like this. Yeah, actually, this is the introduction for AI. We can, yes, right. So guys, yeah, now we can first talk about machine learning. So before we move to this topic, if you have any questions, please feel free to ask. First, you can raise your hand and you can ask the question. And otherwise, you can use chat. If you have any questions, feel free to put them in the chat. I can answer. We can discuss about it. Yeah. So do you have any questions so far? If anyone has questions, please feel free to ask. Yep. So I think you don't have any questions so far. Yes. So let's move to our next topic, Introduction to Machine Learning. Okay, guys. So before move to machine learning, I will start from this traditional programming stuffs, right? I think most of you have experienced what is traditional programming. Like you may have used Python, C#, C++, those kind of languages. And you may have solved so many problems using programming languages. And so I will start from there and I will explain how machine learning, what are the differences between traditional programming and machine learning, and why do we need machine learning for some problems, right? So traditional programming, we can say like, traditional programming, we can say like, we are giving some problem information and we are giving some rules to solve that problem, right? And using traditional programming, we can find answers, right? As an example, let's take these two images, and this gray color area is a conveyor belt. Let's think this gray color area is a conveyor belt. Let's say this is and let's think that this is an image taken from a camera in a some kind of industrial robot, industrial machine or something like that, right? So our task is we have a problem now. We need to detect whether there is an object on the conveyor belt or not, right? That is our task. That is our problem. Let's see how we can solve this using traditional programming. And yes, first we will talk about traditional programming. Yes, let's say you have the ability to do this kind of options, right? Using traditional programming, you can convert this image into grayscale image, and you can measure color intensities in the image, and you can do some cropping stuffs there also, right? Let's say, let's think about using these three options, or one option or two options, how you can solve this problem. My question is how we can detect whether there is an object on the conveyor belt or not. Can you think about that? If anyone has answers, you can put it in the chat. Yes, I will give you around 2 minutes to think, then I will explain. And right. Great, guys. So almost everyone has chose option 2. Yes, exactly. We can do some measuring color intensities, right? Because we can do this kind of task, and you can see actually the answer is there in the right hand side. You can see we can first detect what are the color intensities, and we can check whether is there any green color pixels in the image, and if there are any green color in the image, we can do we can take it as there is an object in the conveyor belt, and if not, we can say that sorry, anyone has questions? Yep. Okay. So, right. If you have any questions, please feel free to ask. Okay. So let's move. Yes, of course, we can use option 2. We can do something like this. First, we can check green color availability in the image, and if green color is there, we can output as object detected. There is object in the conveyor belt. We can, if green color is not there, we can say object is not detected. Likewise, we can classify those images, right? We can do something like this. Actually, this is a very, very simple example. And actually, we can solve this kind of example using traditional programming. So in here, what we have given is we have given relevant problem info or features to the traditional programming. What are the features here? The features is the image pixels, right? We are giving image pixels, and we are giving the rules also. How to classify this into these two classes. The class 1 is object detected and other class is object not detected. We are giving rules and the relevant problem information. And then we are using traditional programming to answer the question. Likewise, we can solve this problem, right? If anyone has questions, do you have any questions regarding this problem? Feel free to ask, right? Yep. I think everyone got the idea of traditional programming, right? Okay, let's move to little bit complex example for now, right? So what about this one? Now, again, if you remember, my question is, I want to detect whether there is an object on the conveyor belt or not, right? So last time we used the option 2, right? For this one, it will work. What about this one? Will it work that that solution for this problem? No, that will not work, right? Because in the first image, in the conveyor belt, we have a object, and in the second image, we don't have a object in the conveyor belt, but there are green color objects in other areas of the image, right? If we took only measure color intensities for both images, our solution will be, our traditional programming module will be give there is object in the conveyor belt, right? So that will not work. So what we can do now, right? To solve this problem, we can do something like this. We can first crop the area of the conveyor belt, and then we can measure the color intensities, right? Like this. We can first crop, because we have this option 3 also, right? We can crop this conveyor belt area, and then we can use that cropped image into option 2. We can measure color intensities. If there is a green color, we can say that there is object on the conveyor belt, right? So we can solve this problem like that, right? First, you can crop the image using crop relevant area, and we can put this cropped image into check green availability. And if green color is there, we can say that object is detected, otherwise object is not detected. So this kind of problem also we can solve using traditional programming, right? But you may have seen, like when our problem become more complex, our code also will become more complex, right? Right. So what about this one? What about this one? Can we use traditional programming techniques to solve this problem? We want to classify in the image whether there is a dog or cat. Of course, this is not a simple task, right? Yes, I can say, yeah, right. So, of course, this is not a simple task, right? That is impossible to use these three simple options to classify these two images. That is impossible, right? Because now it is more complex to make rules by ourselves to classify these images. That's where we need machine learning techniques, right? Yeah. So let's see how we can solve this problem using machine learning. Yep. So please don't write anything on the screen. Chaitana. Chaitana, do you have any questions? Right.
No, sir.
Sorry. Yep, please ask. Do you have any questions?
No, sorry, sir.
All right, no problem. Right. So, yes, let's move to next slide. Then we will see how we can solve this complex problem using machine learning. Sorry. Yes. Yes. Before that, we will take a look at how machine learning is working, how it works. So traditional programming works like this, right? We have taken a look at this in the last slides. Yes, here we have relevant problem info in traditional programming, and we are giving rules also to this traditional programming, and it will generate answers, right? So when we are talking about, we are thinking about machine learning, it is somewhat different. Actually, in machine learning, there are two stages. They are training stage and predicting stage, right? So actually, in the training stage, what we do is we give some examples. Examples means we give some problem info and answers. In traditional programming, we are giving rules. right? Now what we are going to do is we are giving answers and problems to machine learning and let the machine learning algorithms to find rules, right? Now we are not going to derive rules from ourselves. We are not going to derive any rules. We are going to use machine learning to derive these rules. What we only give is we are giving some problems and answers and let the machine learning to derive those rules. And in the predicting stage, what we do is we use these rules and relevant problem information to find answers, right? So predicting stage is somewhat like traditional programming. It inputs rules and problem info and it generates answers. Got it? Right. Yes. Let's go to our problem. How we can solve this problem using machine learning. Yes. Yes. So here, first at the training stage, what we do is we are giving some examples like we are giving this image which contains a dog. This is the problem information, or we call it as features. And we are giving the answer also. The answer is dog, right? And for this image, it contains a cat, and we are giving the answer also. And this image contains a dog, and we are giving the answer. Likewise, we are giving the problem and the answer. We are showing so many examples for to machine learning, and it will figure out what are the connection between this answer and the problem features, right? Problem features means these pixels of the image, and the answer is whether it is cat or dog, right? So machine learning will figure out, those algorithms will figure out what are the connection between these features and these answers. Answers, we call it as labels, and image pixels, we can call it as features, right? Features and labels. So after that, what machine learning do is it will generate rules according to these connections, right? Technically, we are calling those rules as trained model weights, right? Yeah. So, yes. So we are calling those rules as trained model weights, right? Then after that, at the predicting stage, what we do is we use these generated rules or trained model weights to solve these problems, right? And it will generate answers. As an example, first we input this image, and it will use these rules to generate the answer, right? And if you put this image, it will use this to generate the answer, right? Yes, simply this is that is how machine learning is working, right? So do you have any questions so far? If you have any questions, please feel free to ask. Yep, I will give you 1 minute. If you have any questions, you can ask through chat, or you can unmute your mic, and yes, feel free to ask. Right. I hope, yes, I think anyone, you don't have any questions so far. Yes, let's move forward. Right. I believe that now you have some understanding about how machine learning is work and how machine learning and traditional programming techniques are, how we can differentiate them. What are the differences between them? I think you got the idea. Right. So, yes, let's move forward. So, the next question is, what is this machine learning? What are the algorithms available to find the relationships between these images and labels, these features and labels? So these are the data. We are feeding those data to extract rules, and after that, we are using machine learning to do predictions, right? So what are the algorithms we have? Yes, there are so many algorithms we have in the machine learning domain, like linear regression, logistic regression, decision trees, random forests. So there are so many algorithms. Yes, and also these algorithms, almost these algorithms are very simple algorithms. And yes, you can simply search about these algorithms. I am not going to go one by one because it will take so much time. So yes, you can simply search it on YouTube. There are so many videos about these algorithms. You can watch those videos and take an understanding about how these algorithms are working. And yes, but these are very simple algorithms. These 1, 2, 3, 4, 5, 6, 7, 8, 9. These are simple algorithms, simple machine learning algorithms. But when we come to 10 and 11, these are algorithm sets actually. Reinforcement learning algorithms, right? There are so many algorithms under this reinforcement learning algorithms. And next we have deep learning algorithms. So yes, under deep learning algorithms also we have so many algorithms. Yes. So machine learning means the set of all of these algorithms, and deep learning is a specific area of this machine learning, right? Yes, actually, this is not the total list of machine learning algorithms available. There are so many algorithms, but these are the major algorithms that we can see here, right? Yes. Yeah. So that's all about the machine learning. So let's move to deep learning. What is deep learning, right? So as I mentioned before, machine learning is it is the toolkit for artificial intelligence, right? And inside this machine learning, we have this deep learning. It is a subset of machine learning. Deep learning is a subset of machine learning. Yep, Harsha. Harsha has asked that can we create our own? Of course, you can create your own algorithms also. Yep. You can first take actually to create your own algorithms. It is something like this, right? Yes. If you have the knowledge and experience in these algorithms, you will have some a pattern how these things are working. Likewise, you will be understanding them better. Then you will have some ideas how to make like how these algorithms we can use for a specific task. Likewise, you can train your own algorithms, and sometimes you can make new algorithms as well. So I think before that first you have to get a basic understanding of these algorithms, then you can move forward. Of course, you can make your own algorithms. Yep. Yes, Harsha, did I answer your question? Harsha, are you there? Yep. All right. Yes. So yes, sure. Right. Introduction to deep learning. So these are yeah, I will. Yes. Okay, so deep learning, as I mentioned before, deep learning is a subset of machine learning, and actually deep learning is based on neural networks, right? Neural networks. And yes, there are so many neural networks types also. I have listed some of them. Yes, we have standard neural networks and convolutional neural networks. And I have put this task list also, like standard neural networks we can use for classification and regression problems simply, not only for these tasks. We can use these standard neural networks for so many tasks, but these are only examples, right? And we have convolutional neural networks. This is the next network type in deep learning. They are actually widely used in computer vision applications. Yes, and we have recurrent neural networks, RNN, and LSTM networks. Actually, these are suited for sequential data, such as time series, natural language processing tasks. To solve those kind of problems, we can use these recurrent neural networks and LSTM networks. So I am not going to explain every kind of networks here because it will take so much time. Yes. Then we have transformer networks. Primarily, these transformer networks are used in natural language processing tasks, such as machine translation, text generation, and language understanding kind of stuffs. Actually, this black color area is we can say these are the building boxes to learn deep learning, right? To learn to use deep learning, these are the building boxes, right? And using these building boxes in the current world, we have very complex models also, right? As an example, this green color area, you can see generative adversarial networks. We call it as GANs, right? GANs are used for generative new realistic data. You may have seen that AI can generate some images, right? You are putting some phrases in English, and it will generate an image for you, right? You may have seen that kind of tools are there right now. And generative pre-trained transformer, right? The example for that is ChatGPT, right? GPT models are designed to generate human-like text and have achieved significant advancement in natural language understanding and generation, right? Yes. Then we have these diffusion networks. Actually, these diffusion networks also has generative capabilities, right? Same like generative adversarial networks, GANs. Diffusion networks also using these networks also we can use to generate images likewise, right? So these are some kind of trending models in these days. right? And a lot of researches are going on. And I have seen there are so many research positions and job roles also there in this generative AI side, right? Yes. So these are some kind of network types in deep learning. Yes. Right. Actually, I think you got basic understanding of what is machine learning and how machine learning is working, and what is deep learning, and what are the network types in deep learning, what are the algorithm types we have. Right. So now we will discuss about computer vision. All right. Yes. So as I mentioned before, this computer vision is a main field of AI in the, yes. Yes. This computer vision is a main field of AI, right? So why do we need computer vision? This is the way that a computer can see the world, right? This is the way. This is the technology that a computer or machine can see the world, right? So that's why we need computer vision. There are so many applications, mainly robotic applications. We need computer vision, right? So actually, yes, in here also you can see computer vision is a field of artificial intelligence that enables computers and systems to derive meaningful information from digital images, videos, and other visual inputs. And there are mainly 6 tasks in the computer vision. Yes. So actually, there are so many tasks in the computer vision, but these are the main task set we have in the computer vision, right? So the first one is image classification. What is image classification? We are giving some images and we are asking our computer vision algorithm to classify them like this. Yellow bird in here. Yes, this image has classified as a yellow bird, and this image has classified as a yellow bird, and this image has classified as a blue bird, and this image has a classified has been classified as a green bird. Likewise, we can use some, yes, some kind of algorithms, some kind of computer vision algorithms to do some kind of this kind of image classification task. And also next task is object detection. Object detection is something like this. We are giving an image and we are asking to draw a bounding box around every object, not every needed object actually, right? So this is the next task in the computer vision. So, this is also very useful task in most of robotic applications. We have to detect objects. We have to see the world, and we have to detect objects in the machines, right? So then only we can take some decisions according to the environment. So this one also a very important task in the machine vision. And we have semantic segmentation. Semantic segmentation is nothing but we are classifying each and every pixel of the image, of a given image, into a specific class. Like in here, it has classified this pixel area to class blue, or class blue means it is a car. And this green color area is for human. Like here also there is a human, here there is a human. Likewise, we can use semantic segmentation algorithms to classify each pixel in an image to a class, right? And instance segmentation. Actually, this instance segmentation also a computation task, like same as semantic segmentation, but it is little bit different. Like you can see that in the semantic segmentation, this area is corresponding to a car class, right? This is a car. And this area also, it has categorized, it has classified into a car class, right? And but in here, instance segmentation, you can see this is a person and this is the next person, right? It has differentiate person to person also, but semantic segmentation, it can't differentiate. This is a car, this is another car, but it only detect these pixels are related to car pixels only. But in here, instance segmentation, we can more classify this person class into two classes, right? This is person one, this is person two, this is person three, likewise, and this is an umbrella. And this is another umbrella, this is another umbrella, likewise. That's why, yes. So instance segmentation also a very useful task in computer vision. And after that, we have this key point detection. Key point detection is nothing but, as you can see, in some applications, we need to detect key points in a face or maybe in the body, or maybe in any other kind of object. We need to detect some key points, especially in robotic applications. Yes, that is the task of key point detection. And we have this video classification also. In here, we are giving sequence of images, and our computer vision algorithm should be able to classify whether what is happening inside this video script, right? So of course we need a sequence of images for that task. Yep. So these are the main tasks available in the computer vision domain. Yes. So why CNNs for computer vision? Actually, for as I mentioned before, we are mainly using CNNs to develop algorithms for computer vision tasks, right? The reason behind that is convolution neural networks are widely utilized in various computer vision tasks. CNNs have exceptional feature capturing abilities in images, achieved with relatively fewer parameters compared to standard neural networks. Actually, this is something like, actually, this CNNs has a better feature capturing abilities. Like not like standard neural networks. It has better feature capturing abilities in images, right? So that's why we are mainly using CNNs to solve computer vision based tasks. And also it can like this parameters means like, let me show you. Yes, as you can see, as you may remember, at the training stage, we are first generating these rules at the training stage using machine learning, right? So we are calling them as trained model weights, and also we are calling them as parameters also, right? Parameters means these rules. So in CNNs, we have a small amount of parameters compared to neural networks. So that means the model size will be less compared to neural networks, and it will have better feature capturing abilities. Yes, so that's why we are using CNNs for computer vision. And yes, the next thing, what are the algorithms tools available for computer vision tasks? Yes, of course, you may have seen, yes, when we are talking about computer vision, the main algorithms that come into mind is YOLO. So this is a very powerful algorithm, YOLO algorithm, that it is also built using CNNs. Actually, all of these algorithms and toolkits are based on CNNs, right? As I mentioned before, CNN is a building blocks, and these are kind of algorithms that uses CNNs. And YOLO can be used to do image classification, object detection, segmentation, likewise. And as a note, YOLO has higher speed processing and reasonable accuracy, which fits most of the real-time tasks. Actually, this YOLO is considering the most speedest algorithm for image classification, object detection, and segmentation. So that's why we can use this algorithm for real-time task, right? So actually, this is a very good algorithm for robotic task because most of robotic tasks needs real-time object detection, right? Yes. In other hand, we have RCNN algorithms. There are so many algorithms inside this RCNN family, like mask RCN, yes, fast RCNN. Likewise, there are so many algorithms. They also can do classification, object detection, segmentation. Actually, these algorithms have higher accuracies, but slow processing. Sometimes it will take 5 seconds to process only one frame, but the accuracy is very high compared to YOLO, right? So when you are choosing an algorithm for your specific task, you have to consider these two, right? The first one is, do you need higher speed for your application, right? Or do you need high accuracy? If you don't care about the speed, but you are caring only about the, sorry, if you don't need the speed, but you are only caring about the accuracy, then you can go with RCNN algorithms. And if you are only caring about speed, you have to nothing to deal with the accuracies, you can use YOLO, right? Likewise, you can select algorithms and you can train those algorithms using your own data, and you can use them. Yeah. Then we have this open pause. This is a toolkit actually. We can use this toolkit to do pause estimation, key point detection task, and also MediaPy. We have MediaPy. This one also a toolkit developed by Google. There are a lot of computer vision algorithms inside this toolbox. You can train them and use them pre-trained algorithms. Likewise, yes. So yes, this is actually about computer vision. Right. So yes. So up to now, do you have any questions? Yes, if we want to capture the emotions in a face, happiness, sadness, etc., do we do it under key point detection? Yes, actually, there are several methods. It's better to always try to read papers, right? Yes, you can read research papers. There are so many methods. I can give you a small way to solve this task to capture emotions. First, you can use this open post. Let me draw it. So you are saying you want to capture, let's say this is an image and you have a face. Sorry about my drawing. Right. You need to classify, you need to detect the emotions, right? You need to classify whether this person is in happy mood or sad mood likewise. So you can first use a key point detection algorithm to detect these key points, like mouth positions, right? And this eye positions. Likewise, we can do, first we can use key point detection, then we can feed those key point detection key points into another algorithm that don't need to be a CNN algorithm. That could be a normal standard neural network. Standard neural network, I will say it as neural network, and you can classify using yes, you can classify that image using this neural network. Like this is sad, this is happy. Like you can use this kind of techniques to solve your problem. You can cascade two algorithms. Yes, you can cascade two algorithms. Otherwise, you can, another way is you can do something like you can use a larger model, and you can feed image directly without doing any post estimation, key point detection task. We can direct feed images into the CNN model. That could be, you can use, I think you can use YOLO also to classify those images, right? You can take YOLO model, let's say YOLO or RCNA directly, you can use them. The CNN model could be YOLO or RCNA. And directly you can predict whether this image contains a person with emotion of sad or happy, likewise. You can go, you can use any kind of technique. Otherwise, you can use both and you can compare the results, and you can use the highest accuracy one. Likewise, you can do, yes, likewise, you can solve those problems. Yes, I think I have answered your question, right? Yes. Right. If you have any questions, yeah, great. If others also has any questions, please feel free to ask. Right. Yes, that is about computer vision. Right. So now we know how machine learning works, and at the industry, what will happen? Let's talk about this little bit. at the industry, actually, yes, yes, I will take a very, very small example. Let's say, actually, this is a very, very small example. In the industry, we don't have this kind of example. Let's say you are developing a model to classify cat and dogs, right? So what you should have? You should have a database of large amount of data of cats and dogs, right? Images. You should have image set and with answers, right? You should have answers also, right? So that means you should have some data, right? So in the industry, actually, each and every machine learning task needs a lot of data, right? Especially for deep learning algorithms, they need a lot of data, sometimes petabyte of data. To have a good accuracy, we need sometimes petabyte of data, right? Yes, so you have to fetch data, you have to find data from somewhere, and you have to do cleaning. Sometimes there will be false data also. Likewise, there will be a cow in a picture and labeled it as a dog, right? Those kind of wrong information will be there. If we give those information to a machine learning model will be confused, right? So we have to clean those data, and we have to do preparation also, right? After fetching, cleaning, and preparation of data, we can use a model. We can use a machine learning model and train it. Let's say you are using YOLO. You are using YOLO, and yes, let's say you are using YOLO, and you are preparing a very big data set of cats and dogs. And after that, you have to evaluate the model. Evaluation means what is your accuracy, right? There are so many accuracy metrics available. For classification problems, we can use directly accuracy. And there are so many accuracy metrics available. Actually, as an example, if you took computer vision task that we called object detection task, we have to take care of MAP value, mean average precision. Likewise, there are different kind of accuracy metrics available. So using those correct accuracy metrics, you have to evaluate the model after training the model. Let's say you got around 80% of the accuracy. That means if you show hundreds of images to the model, then it will predict 80 images as a corrector, right? Right. Let's say you got 80% of accuracy, and after that you can deploy it to production. Deploy to production means that is not enough to only having a model. You have to use it. To use it, you have to put it into a server, or maybe in an edge device. Edge device means, let's say you are working on a robotic application. Let's say, yes, let's say robotic car. So, and yes, and there is a camera in the top of robotic car, and this camera is going to detect cats and dogs, right? So in that case, you have to deploy this model inside this car, right? Inside this car, you will be having some computer like Jetson Nano or something like computer, maybe Raspberry Pi or Jetson Nano or separate GPU. Likewise, you can have some device to run this trained model. So this kind of work we are calling, this kind of computation we are calling as edge computing, right? We can call it as edge computing. And other computing type is cloud computing, right? Cloud computing means you can deploy this model, your trained model, in the cloud. AWS, Azure, you can use any kind of cloud service and you can deploy it there, and anyone can use your model. Like you are using ChatGPT, that is deployed on cloud, and you can access to that ChatGPT model. So you have to deploy it, then only you can use it, right? So after training your model, after evaluation, after you have good reasonable accuracy, you can deploy it, right? After that, that is not enough. You have to monitor it. Like, why do we need to monitor it? Let's take now. Okay, I will take another example. Let's say you are going to build a face recognition system, and you have used lot of faces. Yes, faces from Sri Lankan people, right? Sri Lankan people images. You have used Sri Lankan faces to train your model, right? We are developing a face detection model, right? Face detection model. Then let's say, and you got a very good accuracy. Let's say MAP of 90%. You got that kind of very reasonable accuracy. And okay, now you have a good accuracy, then you deployed it into production. That means you deployed it in on a cloud service, right? Then users are coming and using your service to detect faces, right? So at the monitoring stage, we have to think what are the target audience. Likewise, let's say if users are from Sri Lanka, then no problem, because you have used Sri Lankan images to train the model. Then you are predicting after deploying it, the users are also from Sri Lanka. Then you don't have any problem. But let's say your model is used by let's say USA people, then what will happen? Then your accuracy will be very less. The reason is your model only have seen Sri Lankan peoples, right? Your model haven't seen any kind of white people, right? So in that case, our model will fail, right? So you have to monitor. Every time you have to monitor your models, how it performs. Likewise, there are so many. This is only one example. Even though you have a better accuracy, it will fail on the production. It can be, right? So in that case, once you monitor this problem, next time you have to collect more data on USA people also. Then you can go through this circle again and again. You can monitor, train again your model. Likewise, you can have a very good reasonable accuracies, right? So there are so many things we have to do in the production, if in the industry. If we are making some algorithms in the industry, we have to take care of all of these stages. We have to take care of this data and model training and evaluation, and then production also, right? So in that case, there are so many rules available, right? There are so many rules available. There are so many theories available. So they are under the MLOps, right? This is a very important subject, machine learning operations. So under this subject, you can read MLOps, short of machine learning operations, refers to the set of practices and tools used to streamline the deployment, management, and maintenance of machine learning models in production environments. It combines principles from machine learning, software engineering, and DevOps to address the unique challenges that arise when operationalizing this and scaling machine learning workflows, right? So what are the challenges actually? We have a challenge in deployment and integration. And we have to think about ethical and legal considerations also. You can't use, let's say, you can't use people images, people faces in your model to train your model without having permissions, right? Do you like if someone uses your face somewhere to train your model, train their model, right? So there are so many ethical and legal considerations also. So we have to learn them and we have to make good practices. Right. And also we have data quality and availability. We have to maintain a good quality data and we have to check the availability also. There are so many theories behind that. So if you are interested in those things, you can learn MLOps also, right? And model selection and hyperparameter tuning. You have to always tune your models to have better performance. And you have to monitor your model and you have to maintain your model, right? So in this, to address all of these challenges, you have to learn MLOps, machine learning operations, right? I will give you some materials, some resources to learn these stuffs like machine learning, deep learning, machine learning operations, likewise, right? At the end, I will provide you those information and I will give you the roadmap to learn machine learning. I think for now also we have covered so many things. Yes, right. Yes, we have another question. In ML pipeline, what are the steps that are responsible of machine learning engineer? Do all the steps are done by machine learning engineer? No. Yes, very good question. So for the machine learning engineer, actually, yes. Yes. Actually, for the machine learning engineer, his tasks are mainly yes, laser point. Yeah. No, I will use pen. Right. Actually, machine learning engineer mainly focus on train models and evaluating models. This is the ML engineer's task. Actually, not only that, right? Sometimes you have to do these tasks also. That depends, but that is the reality. Sometimes you have to manage these data sets also sometimes, right? You have to analyze those data also. It depends on the company that you are working, but normally what machine learning engineers do is training model and evaluate model. And data scientists should capable of handling all of these things. And yes, these things handled by MLOps engineers. But if you are a machine learning engineer, you should have the understanding of how this circle works, right? Yes. Did I answer your question? Yep. Yes, we have another question. Great. So in a certain where a suitable data set would not be available, we may have to create our own data set. Is it possible to create a data set, and what would be the general process? Could you tell it briefly or recommend any materials? Yes. So yes, in this AI domain, the data is a really important thing, right? So in most of cases, we don't have enough data. So we have some solutions for that. Yep. Right. Let's say, I will give you a brief example. Let's say you want to okay, let's say you want to do something like this. You are developing a gender classification model for Sri Lankans, right? This is a gender classification models. No, I will take another example. Let's say you are going to let's say you are going to make a model to detect license plates in Sri Lanka, right? Detect license plates in Sri Lanka. Sri Lankan license plates, right? So in that case, you should have Sri Lankan license plate dataset, right? But do you think that you can will you able to find a data set for license plate in Sri Lanka? Sometimes not, right? Sometimes it is very difficult to find a data set. In that case, what you can do is you can find data set of license plates from another country, right? Let's say USA. There are so many publicly available data sets, right? And you can train your own model using those. Let's say you found 10K images from USA, right? Then what you can do is you can use these images to train your model, but it will train for USA images, right? You can train your model, ML model. Then what you can do is you can collect a small amount of data from license, Sri Lankan license plate. Let's say you collected 500 images, right? Of course, if you only use these 500 images, that would not be enough, right? But after you trained your machine learning model using USA dataset, what will happen is most of the parameters will be trained in the machine learning model with USA dataset. It is a very large dataset, and machine learning model has it has the capability of detecting most features, most of the features in the images. Then what you can do is you can do transfer learning. There is a term called transfer learning, right? You can use these 500 images to do transfer learning. Then you can fine tune your model into your dataset for Sri Lankan dataset. Then you can have a very good results, right? So I would recommend to learn about this transfer learning stuff. That is one solution. And yes. And create our own data set. It is possible to create a data set, and what would be the general process? Yes. Actually, the process is, let's say, first of all, you can do something like this. You can reduce your data set into, you can use a small amount of your own data. As in this example, you can use only 500 images. Then to collect this data set, you can use tools like RoboFlow. Actually, that is really depends on your application. If it is a image processing thing, you can easily use this RoboFlow, and you can collect some images using your mobile phone, or you can collect those images by your own. I think 500 images is not that difficult to collect. And then you can use some annotation tools like RoboFlow, and you can prepare your data set. And there are some other methods also. You can do some what they called yes, I don't remember the name. Yeah, there was another method to data augmentation. Yes, you can you can use some data augmentation techniques to increase your data. Like these kinds, this kind of solutions are available, right? And also, yes, actually, I have given you mainly two answers. That is, one is transfer learning, and other one is data augmentation. Using that, you can simplify your data collection process, right? After that, you can collect data. Yeah, I think you got the idea, right? Great, great, right. Okay. Right. So this is the, let's get back to the slides. So can we use data synthesis? Yes, we can use synthesized data also. Yes, there are some techniques like you can generate some data also. Some kind of techniques are there. Like if you, I would recommend you to follow this RoboFlow. They have a lot of tools there to generate data and process data and annotate data. Most of data solutions you can find in this RoboFlow. Yes, great. Yep, and this is MLOps. Yes, this is our next part. I think yes, I think we have completed our first part. If you have any questions or comments, please leave it on the chat, or you can unmute yourself and ask directly, right? Okay, so let's move to our part two, path to the industry. So in here, we will be discussing about common skill set that may be helpful to you, and path to get your first job, and path for, tips for LinkedIn. Right. Yes, I have listed these common technical skills that you may beneficial to you. So in this orange color, actually, if you are a beginner, if you are a very beginner, make sure that you have covered this orange color skill set first, right? These are very important to have any kind of role in the AI industry, right? That could be a data scientist, that could be a ML engineer, that could be a research side, or any kind of AI positions. It is very, very beneficial to have this skill set, right? The first one is Python. You should have a good knowledge of Python programming language, and because in the industry, mainly we are using Python for AI tools, right? You should have the skill in OOP. OOP means object-oriented programming, and learn about NumPy, Pandas, Matplotlib, Seaborn, Flask. This kind of knowledge would be beneficial to you. And you should have the experience in ML/DL frameworks, machine learning and deep learning frameworks. This scikit-learn is a machine learning framework, and PyTorch and TensorFlow deep learning frameworks. Experience in these frameworks, it is really, really important, right? And mathematics, I think most of you guys are from engineering, maybe from not engineering, you are undergraduates, right? So definitely you should have mathematics modules. So I think this might not be a big issue to you, but it is important to have probability and statistics knowledge, and calculus, very important, and linear algebra and numerical methods. These are very, very important mathematical skills you should have, right? And you should have knowledge of ML/DL algorithms, basic ML algorithms. I have already shown to you what are the basic ML algorithms, and deep learning techniques. You should be able to implement your own convolutional neural network, standard neural network, and like RNN, LSTM, and you should be able to retrain a model like YOLO using your own data set. That kind of knowledge would be really, really important when you are going to the industry. Yes. And version control systems. Actually, most of job posts you can find, they are requesting knowledge of version control systems, but others are not. But according to my experience, you must have experience in understanding of version control systems like JIT, right? It is very, very important. It is actually easy for you when you are going to the industry. It will really, really helpful to you. Yes. After that, actually these orange color ones are the basic skill set you should have. And in addition to that, you should have data analysis and visualization skills. You can use Pandas, Matplotlib, Seaborn, and NumPy for that. And if you are if you want to become a data scientist, sometimes very important to know languages like R. It is a really great language to visualize data, do statistical analysis on data, and do visualization on data really, really easy with R language, right? And you should have some kind of data handling, feature engineering, and pre-processing knowledge. That means techniques for data cleaning, how to clean data, how to do normalization, dimensionality reduction techniques, and dealing with missing values, and knowledge of databases like SQL dataset would be an advantage to you, right? And this is not compulsory thing, but that would be great if you have this kind of experience, also this kind of knowledge. And that means cloud. If you have knowledge in cloud platforms like AWS or Azure, that would be great. You will be easy. You will be getting when you are going to the industry, that would be easy for you, having knowledge in the cloud systems also, right? Yep. Right. These are the roles available in the industry right now. AI engineer. And actually here we have yes, 6 roles are available, mainly 6 roles are available. Not that even though here we have AI engineer, there is another role related with this AI engineer role, that is research AI engineer and machine learning engineer. We have research machine learning engineer or machine learning research engineer, right? And NLP engineer, and there is another role called research NLP engineer, research computer vision engineer. Likewise, that kind of roles are available, right? Let's talk about AI engineer. They specialize in designing, developing, and implementing AI systems and algorithms, right? They work on tasks such as data pre-processing, model development, training. Actually, mainly model development and training and deployment, right? You saw the life cycle of machine learning projects, right? So AI engineers are mainly focused on model development and training, right? But they should have the knowledge in data pre-processing and the deployment also, right? Yes. And for the machine learning engineer focus on creating and deploying machine learning models and systems. They are skilled in selecting appropriate algorithms, fine-tuning models, and optimizing performance. Likewise, actually, this machine learning engineer also mostly like AI engineer. He or she should be able to select more appropriate algorithms and train and fine-tune them. Yep, we have another question. Yes, what is the procedure to be AWS certified machine learning engineer? Is there any exams for that? Actually, I don't know about this. Yes, you can learn AWS things from online. You have so many courses in Coursera, and AWS also has some courses, and I saw some courses are there. Yes. 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 Someone said that paid exams are there. Yes. Yes. To be AWS certified machine learning engineer, as I remember, they had a course set, and they had some exams. He said that paid exams are there. Yes, that could be the path to become an AWS certified machine learning engineer. So it is better to do some research on that. Yeah. Yeah. Okay, let's move to the next part. Yep. Yes, we are in the machine learning engineer part. Okay, for the data scientist, Actually, data scientists are mainly focused on analyze and interpret large data set to extract insights and develop predictive models. They work on data cleaning, feature engineering, statistical analysis, and model evaluation. So that's why if you want to become a data scientist, you should learn R also. This R language is very powerful language to do analyze data and do statistical analysis on data. This R language is very, very powerful tool, powerful language, right? In addition to that, data scientists should have the knowledge in model selection and model training and deployment also, right? But the main focus area for data scientists is dealing with data, right? Then we have natural language processing engineer. They are specialized in developing algorithms and systems for processing and understanding human language, right? They work on tasks such as sentiment analysis, machine translation, chatbots, and text summarization. Of course, ChatGPT also a development from natural language processing engineers. Yep. Yes, then we have computer vision engineer. Computer vision engineers focus on developing algorithms and systems for image and video analysis. They work on tasks like object detection, recognition, segmentation, and image generation. I have already shown what is computer vision, and computer vision engineer should have those skill set. Yep. And robotics engineer. Robotics engineers design and develop intelligent robots and autonomous systems. They work on tasks such as robot perception, motion planning, control systems, and human-robot interaction. Actually, in here you can see in robotics we have to use we have to deal with natural language processing stuffs, and sometimes we have to use computer vision stuffs because there are so many perception modules in robotic applications. Yes, those are the skill set that should have for robotics engineering. Yep, actually those are the main roles available in the industry. As I mentioned before, we have research positions as well, research roles as well. What researchers are doing is, let's say AI research engineers, they are reading papers and they are researching on some new technologies, some new techniques, new algorithms. Likewise, so to become a research engineer, you have to you have to have the skill in reading papers and implementing them and understanding papers, right? That is important skill that research engineer should have in addition to these skills, right? Yep. Path to get your first job. Okay, this is the roadmap actually. First start in here. I am assuming that you are a very beginner for the field of AI. So if you are a very beginner, first start by developing a basic skill set in AI that I have shown before. You have to develop those skill set first. Then as you work on these skills, you will discover which areas of AI you enjoy the most, such as computer vision or natural language processing. You can then choose to specialize in that particular field. However, it is important to note that even if you decide to specialize, it is beneficial to have reasonable knowledge in other areas of AI as well, right? It is okay to specialize in computer vision domain, but a little bit knowledge in NLP also should be beneficial to you, right? Yes, and showcasing projects. So if you are an undergraduate you don't have industry experience, right? You will have some training experience, but you may not have good to showcase your experience in this field. So the best way to show your skill set by doing projects. You can do your projects, and you can show those projects, and you can put them in your CV, and you can share them. That's the way you to showcase your skill set, right? You have to do so many projects and improve your curriculum vitae. Meantime, improve your curriculum vitae by adding completed projects, right? Maintain your LinkedIn profile. This is very, very important, guys, where you have to, okay, I will explain this later because we have another slides, favor slides to explain about LinkedIn, right? Then you can join some open source projects, such as an example, we have Omdena. They are doing like, they are collecting people from different countries, and they are doing some open source projects. You can join them and learn them, work with them. Yep, that would be beneficial to you to gain much experience in this field. Yes, these are the tips for LinkedIn profile. I have seen yes, there are so many LinkedIn accounts that are not in a standard way, right? So that's why I put these points in here. So I will explain this. First, use a professional profile picture. Always try to use a professional profile picture in your LinkedIn profile. I think you all know what is LinkedIn, right? It is a it is a social platform like Facebook, right? But it is professional, right? Yes. For the profile picture, always try to choose a high quality photo that presents you in a professional and yes, approachable manner. And never choose a selfie as your profile picture, right? Never choose a selfie. Be professional, and do not use sunglasses or flashy accessories. Be simple but professional, right? And keep smiling. Yeah, that is really, really important. Yes, and you can craft a compelling headline. Your headline appears under your name and should quickly summarize your expertise and value. When you're commenting or sharing something in LinkedIn, under your post or under your comment, under your name, everyone can see your headline, right? So it is really, really important to use a good headline for your LinkedIn profile, and showcase your experience. That means in your profile, list your work experience, including job titles, companies, and key responsibilities. If you are an undergraduate, you may have some training experiences. You can put them under experience topic in their LinkedIn profile, and write a concise and engaging summary. Write a summary about you. Your summary should provide a brief overview of your professional background, skills, achievements, and career goals, and make it compelling and highlight your unique strengths as well. Right. After you have a good quality LinkedIn profile, engage in networking, right? Connect with professionals in your industry. If you are try to become an AI engineer, then try to connect with AI engineers in LinkedIn, right? Then the important thing is, guys, they will share very, very updated information on LinkedIn. You can learn a lot of things from them. There are so many very experienced people there. They are sharing very important stuff and their knowledge. That is very, very important. And not only that, some people, some professionals they are putting some jobs in their profiles, and sometimes they are providing some opportunities to join with them. Likewise, so it is better to have a good network with your LinkedIn profile, right? And try to maintain at least 500 connection in LinkedIn, right? This is somewhat important thing, guys. Try to at least have 500 connection in LinkedIn, because let's say when you are going to a profile and it only has 100 connections in their LinkedIn profile, then you may feel like this guy is not that much a forward guy, or that much involved in social media things. But when you have much connections on LinkedIn, it shows that you are active, right? That you are active on this platform. Then if someone comes to your profile with a great opportunity, he will contact you, right? Because your account is showing that you are active in this platform, right? Yes, so that is important tip. Actually, this is a tip, right? And request recommendations. This is also an important thing. When you are going, yes, when you are joining to a training position, as an undergraduate, you will join some companies and you will have some supervisors and request recommendations from them, right? Try to ask a recommendation from them. That would be really, really beneficial to you when going to new jobs, and because everyone can see those recommendations on your LinkedIn profile, right? And share and create valuable content. Share industry-related articles, insights, or your own professional content to demonstrate your expertise. This helps you establish yourself as a thought leader and increase your visibility, right? And also, please don't share any funny stuffs or like what we called yes, inappropriate things. Always try to be professional. Only share professional stuffs there, right? Yes. And after that, actively seek and apply for job opportunities. Utilize LinkedIn's job search feature to find relevant positions. Apply directly through LinkedIn when possible, and follow companies or organizations you are interested in to stay updated on their activities, right? Yeah, those are the tips to have get your first job. Yep. Do you have any questions? Anyone? Yep. If anyone has any question, please feel yes. Can you share what are the books and courses? Yep, sure. I will share at the end of the presentation. Sure, I will share information. Yep. Actually, personally, I haven't read any machine learning books because I'm lazy to read, actually. That's the reason. But I love to follow courses. So I will give you some course systems, course links you can follow. Right. Yep. Then, yes, those are the tips for LinkedIn. And tips for projects. Yes. how to select a project for you. The first question, choose an area of interest that you're finding appealing, such as NLP, computer vision, reinforcement learning, or generative AI. So when you are getting your basic skill set, basic knowledge, you will feel like I love this field so much. Like I love natural language processing than computer vision. Someone says like I love computer vision likewise. So first find what is your interesting area, right? That is must. Yes. Then conducting research on industry trends can be beneficial. Yes, you have to do a small research. What are the industry trends? Currently, what are the industry trends that we have? Like one way to do this by actively engaging on LinkedIn. As I mentioned before, at the LinkedIn, you can find very skilled people, and they are sharing very valuable information. We can learn from them, right? So and also they are very, very active. So in that way, we can understand what are the trending areas in AI right now, like us. Yep. And yeah, and also additionally, YouTube provides yes, you can use YouTube, you can watch videos, and there are very, very very good YouTube videos, YouTube channels available. You can follow, subscribe them and watch their new videos, and they also sharing very, very valuable stuffs, right? Moreover, platforms like Kaggle host numerous data sets and project notebooks that can provide practical examples and applications of industry trends. Especially because there are some competitions in Kaggle, you can follow them, and in Kaggle, they have very, very big data sets as well. You can download them and play with them, and you can develop some algorithms. You can train some models using those data. And also people are sharing notebooks and projects, their projects also in the Kaggle platform. So this Kaggle also very, very important platform to you, right? Yes. Right. Should your projects always be null? Actually not. I put this question here because most of undergraduates struggle here. They think like, if I am going to get a opportunity, I must have a novel project. But actually that is not the case. Your projects do not need to be novel ideas. You can choose to work on any kind of project that interests you. However, the basic idea of doing projects is to gain your skill and showcase your understanding, capabilities, and capacity, right? That don't need to be novel, but if you have a novel idea, that would be great, right? But that is not a must thing. You can do any kind of project, no problem. And how many projects? Actually, it depends. Having diverse range of projects within your field of interest can be helpful in securing your first job. Engaging in projects also offers the benefit of gaining a deep understanding of how things work. So, as an example, when I am getting my first job, I had around 10 or 11 projects in my CV. Yep. But it depends, right? If you have very, very powerful projects, and if you think those projects are enough to showcase your whole skill set and your capabilities and your capacity, that would be enough, right? Yes, that is the answer for that question. And the fifth question is how to show your projects to others, right? This is an important thing. Like when you are doing projects, you have to share those projects with others, right? So try to make a web app and host them on a platform like Heroku. You can share the project links with anyone. So actually, you can do something like this. You can develop an algorithm. You can train algorithm, and you can host them in a platform like Heroku, in an online platform, in a cloud service. You can use a cloud service to deploy it, and you can put the link on your CV. Then someone is working through your CV, they will see your link, and they will click on that link, and he will be able to use your deployed model, right? Then he or she can have a better understanding about you, right? About your skill set. And upload the project video presentations to YouTube. This is also very good way to showcase your project to others. And you can put those links also in your CV, right? Yes. And you can share your links on your CV as well, and make sure you can explain your projects in detail to anyone. This is a must thing, guys. If you did some projects when you are applying a job, when you are providing your CV to that job, make sure that you can explain your projects in detail to anyone, right? This is must. Yeah. So these are the main tips for projects. So if you have any doubts or any other questions, feel free to ask, guys. Yep. Yep. That's it for this session. Yes. So thank you. If you guys have any question, please feel free to ask now. Yes, we have one question. Sentiment analysis in NLP, does it only includes identify emotions? Okay, we have a question. Sentiment analysis in NLP, does it only include identifying emotions through text, or does it? Oh, I see. You mean in NLP, right? Right. Oh, this one is actually not a computer vision task. This is a natural language processing task. That means you are providing some text, and you have to identify emotions through text. Actually, it doesn't include facial emotions, right? That is, if it is sentiment analysis in NLP, then nothing to do with computer vision things. Yep. Yes. Great. Then we have another question. What are the projects that we can involve in case of ML and AI? I mean, the projects that can be added in our resumes for our future intern programs. Yep. Actually, for that question, like I can say something like this. Go to Kaggle, right? Go to Kaggle, and there are so many projects available there, right? As I mentioned before, it is depending to you. to select your interesting project, right? As an example, the first one is choose an area of interest that you find appealing, such as NLP, computer vision, reinforcement learning, or generative AI. So in that case, first understand what area you are mostly interested in, and then you can go to Kaggle and find some interesting projects from your interesting field, and you can try them. And while doing some projects, you will be having some ideas to improve them, or you will be having some new ideas as well. You can do those things, those improvements. Yes, that's the answer. Yep. Did I answer your question, Safni?
Yes, sir.
Great. Thank you. Any other questions? Yep. I think we don't have any other questions. Yes, then let's wrap up the session. Yes, guys, thank you very much for joining for today's session. And yes.
Thank you, Engineer Chinthaka Jayaweera, for your enlightening and engaging sessions. Your expertise has provided us with valuable insight into the world of machine learning and in these industrial applications. I think no more questions, but I think I have to spend another 2-3 minutes before wrap up of the sessions. For if you have any question, please feel free to ask that questions, or else please put on the chat, or you can directly put all your chats for that our speaker. Then if today he couldn't able for that, we are organizing future sessions as well, then you can get your answer in from that future sessions as well. So we will stay in another 1 to 3 minutes for waiting for your questions. So if you have any remaining question, please feel free to ask for those questions.
Yeah, exactly. Yes, Jamal. Yes. Yes, we have one more question. Hiruna is asking, can you suggest the recommended courses? Actually, I forgot to mention that you asked before also. Actually, I would recommend if you want to learn machine learning stuff, go to Coursera, and there is a course called Machine Learning Specialization from Professor Andrew Ng. That is a very, very good course to follow. And if you are learning deep learning, then also I am encourage you to follow his deep learning specialization course on Coursera. If you follow these two, you will be covering most of the content of machine learning and deep learning. Yep. Yes, Hiruna, did I ask you answers to your question? Great. Yep.
Again, thank you very much. Now I kindly invite Engineer Chinthaka Jayaweera to accept the token of appreciation from the IEEE student branch of the Southeastern University of Sri Lanka in India. Your expertise and engaging session have truly enriched our understanding of machine learning and its industry applications. Thank you again.
Thank you very much, Shamod, and team of AGX. Yes, actually, yes. Thank you very much. Yep.
So now we are coming to the end of the today's sessions. Before the end of the sessions, now I would like to invite our active participants to switch on their cameras and let us get capture of the group photo for the memories of today's sessions. Fazan, Kavindu, please be ready for your end. I will wait 1, 2, 3 minutes until our audience will switch on their cameras. Please switch on your cameras and I will count the give a count. Then Kavindu and Fazan, your end you can capture in our group photo. So I will encourage to invite for all of the people. Please switch on your cameras. We will give 2 minutes. We will give 2 minutes. Please ready and please switch on your cameras and please make of your group photo on today's sessions for the memories. Yes, please switch on your cameras. We will take photos within 1 minute. I think that group photo capturing is very new from that year. So I think that is the reason for that people are not switch on your cameras, but don't hesitate to open your switch on your cameras until that because this is the first sessions of that. So we will get the capturing of that our audience anyway. So Kavidu and Bazan, please took a capturing of that our participants. Then I will took a small count, then give a small cheese and get that our group photo on today's sessions. 3, 2, 1. Thank you all, ladies and gentlemen. As we come off the end of our sessions, I would take a moment of express my heartfelt gratitude to everyone who has made this event successful. First and foremost, a big thank for our esteemed speaker, Engineer Chinthaka Jayaweera, for sharing his valuable knowledge and insight with us today. Our expertise and engaging sessions have truly enriched and our understanding of machine learning and its industry applications. And I would like to extend my sincere thanks for the other academic members, Council of the IEEE Student Branch of the Southeastern University of Sri Lanka, and the organizing committee members of IEEE Student Branch of the Eastern University of Sri Lanka for their support and guidance in the organizing these sessions. Your contribution has been instrumental in this making an event possible. Special thanks to our design partners whose creative inputs have added an extra touches and professionalism to these sessions. Your collaboration with great expertise and appreciated. Lastly, I would like to express my gratitude to all participants who join us today. Your active participation and enthusiasm have made these sessions a truly interactive and enriching experiences. We look forward to your continued support to invite to join us our upcoming sessions. Together, let's continue and explore that explain our knowledge in the exciting field of machine learning. Thanks once again. Have a wonderful night. Good night, all of you.